Okay. Today we can discuss the algorithmic approach to solve the problems. Right? So this is lesson number 3, right? Okay. Then the first one is the define the problem. What is the problem? All right. So in here, the problem must be defined into 3 questions. Right. So if you have problems to solve using the computer, there are 3 main questions. The first one is what are the available data or a data that represent the input of the program, right? Simply we can say what are the inputs, right? So what are the inputs? The second one is what is the method or set of process or process uh, which lead to get the result from the available data, right? So if you have input, then we have to do a particular process to get the result. And then the third one is what are the required results or what is the output of the program? Simply is called output, right? In other words, in computer program, it can be considered into 3 basic process, all right? Actually, 3 basic phases. The first one is input data. So once if we input the data, then we can process over the inputs, and then we can have a result. As a result of the process, we can output the uh, information or a data, right? So what is the input? Input means how and from where to get the input data, right? So input means how and from where to get the input data. The process means what are the operations. Actually, a process means a set of operations, right? So what are the operations and how to perform them on the input data, right? So all the inputs, how to do the process, right? So process means set of operations. Output means how and where to output the resulting data, right? So when you do the outputs, we have to consider how and where to output the resulting data. So when you take the process, what are the operations and how to perform them on the input data, and then input, then we have to consider how and from where to get the input data, right? So in input phase, we have to think about how and from where, right, to get the inputs. In the process, we have to think about what are the operations over the inputs. In output, we have to think about how and to where or where to output the results, right? So it may be into the monitor or it may be into the papers like printouts, likewise, right? So even without the output data, we can store in storage devices, right? So in output phase. Okay, and then when you design solution, right? So when you design the solution or the actually the basic the problem can be dividing into the small steps, right? So problem can be dividing into the some sub problems, right? Then they identify the solution in a sequence of steps called algorithm, right? So for example, if you ask to say calculate the average of your marks, right? Then that calculating average can be divided into 2 main components. The first one is take the summation, the next one is divide by number of subjects, right? Then we can consider the how can we do the how can we solve that problem, right? So first of all, we have to take the numbers, and then we have to do the take the summation or take the total, and then we have to divide by the number of subjects, right? So those are the sequence of steps, right? So if you want to calculate the average, so first of all, you have to take the inputs, and then you have to calculate the total, and then we have to divide by number of subjects. Then we can have an average and then output the average. So those are the steps that we have to follow, or we call those are the sequence of steps, right? Those sequence of steps. So in here, I explain how to calculate the average, right? So I'll explain stepwise, right? So I have to follow the particular order. right? So sequence of steps are called algorithm, right? Have you got it? Have you got it? Okay, then, so as I told you, we have to identify the solution in sequence of steps called algorithm. So sequence of steps are called algorithm, right? And then by following that algorithm, we can write a program, right? So we can write a program, usually called source code, right? So once if you write the source code, we have to check with that source code is uh, uh, satisfy the algorithm, right? So, or that source code is followed the algorithm, right? And then we have to compile it. Compilation means the actually the compiler may find the syntax error in the programs. Compiler means compilation means the check whether the syntax errors are there, right? So you will familiar these things once we start the practical sessions. Compilation. So if some errors are there or if errors are found, it must be corrected and recompile the program again, right? So in your source code, uh, uh, when you compile your source code, the compiler find the syntax error. Sometimes it may, if there is a error, right? So if there are errors in your source code, the compiler find those errors, right? So if errors are found, then those errors should be corrected and recompile the program again, right? Okay, so that's about the design solution, right? So when computer programming as a problem solving, right, there are two main principles, right? So first one is the problem solving principles, right? So first of all, we have to completely understand the problem, and then we have to prepare a plan to solve it, right? So we have to prepare a plan to solve it, and then we have to carry out the plan, right? So we have to follow that plan, and then review the results, right? So according to the plan, we have to review the results, right? So and then if there is a new requirement, we have to add those requirements, right? So when you're developing a program, right? So we have to analyze the problem first, right? So I'll explain the example. I'll take the same example again. Now let's see. Our problem is say finding the student ranking, right? You know what I mean by ranking. Say he is the first one and the second one, third one likewise. So finding the ranking, right? So we have to analyze the problem, right? So how can we find in the ranking of the students? How can we find the ranking? So assume there's a class, right? So among the, say, there are 10 students, right? There are 10 students in your class, in particular class. And then I want to find the rank of those students, right? Actually, assume there is an exam, there is a series of examinations. So say there are 5 subjects, say 3 subjects, right? There are 3 subjects. And then I want to find the rank of those students, right? So how can you do that? Now, my question is find the ranking, right? So first one, we have to analyze the problem, right? So analyze the problem means finding the ranking, right? And then we have to developing an algorithm for the problem, right? So now what is the algorithm, right? So as I told earlier, there are 10 students. I'll take the 1 student, and then I'll take marks for 3 subjects as inputs, right? Then there are 3 inputs, right? There are 3 inputs, right? Mark for the subject 1, marks for the subject 2, marks for the subject 3. There are 3 inputs, right? And then I'll take the, I'll calculate the total, right? Total. And then I divide by the total, divide by the 3, divide by number of subjects, that is 3. And then I find the average of student 1, right? Then I follow the same procedure for all the other students. And then now I have average of 10 students. That means 10 number of averages, right? Have you got it? Now I have average for average of each and every student. Have you got it? Did you understand? Did you understand? I calculate average of each and every student. If there are 10 students, I have 10 number of outputs. Right? Now, did you understand? Now, do you understand the how to calculate the average?
Yes, sir. Understand.
Yes, sir.
Understood.
Then, now I want to find the ranking. Then, now I have 10 numbers. Then, what I have to do? I have to prepare I have to order these numbers. I have to keep a particular order, right? So if I want to find the ranking, I have to prepare into the say descending order. Descending order means I have to arrange those numbers from uh, greatest or the largest to smallest. The largest one, next one, likewise largest to smallest. We call descending order. Descending order. I calculate the average and then I arrange those numbers or the average of students into the descending order, right? Descending order means largest to smallest. Then I can label 1, 2, 3, likewise up to 10. Now, did you understand it? Now, do you understand it? Hello? Do you understand? The steps,
Yes, sir.
Please tell again, sir.
yeah.
Yes, sir.
Yeah.
Sorry? Is it required to explain again? No. Okay. I have to calculate average for each and every student. Then since there are 10 students, I have 10 averages. And then I have to order those averages according to the descending order. And then I can label 1 to 10. So that is my algorithm. Then the algorithm means steps, right? Steps for solution, right? So by using that algorithm, we can test it, right? So we have to test the algorithm, whether it's correct, right? And then we can write the computer program, right? So if you have an algorithm, we can write the computer program, and then we can execute the program. And then maintain the program means assume. Now I consider 3 subjects. So if there are 4 subjects, I have to change my algorithm. So assume there are 4 subjects, right? So if there is 4 subjects, then how can I change that my algorithm? That means number of subjects are increasing. Then how to change my algorithm? I have to change a particular step. How can I change it? What is that step? I told you that there are 3 subjects. And earlier there are 3 subjects. Now I have say 5 subjects. Then how can I change my algorithm?
Dividing 4.
Dividing or 4 or 5, dividing according to the number of subjects, right? So that's called maintaining the problem. That means program. That means according to the newly added requirements, we have to change my program or change my algorithm, right? So first of all, we have to change algorithm and then we can change the program, right? So that's what we mention in maintaining the program, right? Assume in earlier we consider only the integer numbers, right? Now we have changed that integers into the say floating point. Then we have to change the types of inputs, right? Likewise, we have to maintain the program depending on the newly added requirements, right? Now, what is the algorithm? Algorithm means how you go about solving the problem, right? That means your solution to a particular task, all right? So for example, so this is famous example. It's a how do you make a say cup of tea? How do you make a cup of tea? Right? So first of all, we can mention the what you call basic steps, what you call the main steps. Then we can give a fine details. All right. Here I mentioned the basic steps, right? The first one. So as I told you earlier, all right. So this order is very important, right? The first one is boil the kettle and put tea into cup, right? And then pour boiling water into cup, right? So I'll take these steps one by one, right? So in programming, you should plan your algorithm before you start coding, right? So when you are doing the programming as well, right? So you have to plan the algorithm. First of all, you have to plan this, right? So in I think he explained some fine details, right? So he explained some fine details, right? So these are the basic things. Then we can give the fine details, right? So then the algorithm is, right? So actually that algorithm is a finite sequence of instruction, right? Finite sequence of instructions, right? So in algorithm describe what are the things we have to do and in which order, right? So what you have to do and what is the order, right? So that is very important, right? So things we have to do and in which order, right? Then the algorithm produce the solution to the problem, right? Then the algorithm will provide the solution to the problem, right? And then the algorithm is written by the human language, or we call natural languages, right? Basically, we use the English, plain English, uh, to write the algorithm, right? So an algorithm can be converted into any programming language selected by the programmer, right? So if you have a solution, or if you have an algorithm, that algorithm can be converted into the any programming language, right? Okay, then here this is the summary, right? So if there is a problem to be solved, right, then we have to design the algorithm, right? So when you design the algorithm, there are two there are two main methods, right? So to design the algorithm, the one is the flowchart, the other one is pseudocode, right? Then if you have an algorithm, that algorithm can be converted into any programming language. That language may be C, or that language may be Java, or that language may be Python, right? So not only these things, right? You can convert our algorithm into the any programming language, right? Okay, then what is the flow chart? Actually, flow chart means the graphical representation of an algorithm, right? Flow chart means the graphical representation of an algorithm, right? So then here they indicate the order in which the actions are to be performed, right? So as I told earlier in the algorithm, the steps or the what we have to do and into the which order, right? In the order is important, right? So in here they indicate the order in which actions are to be performed, right? So action means the steps and then order, right? So there are some basic symbols that we have to use in flowchart. So these are those symbols, right? So here the rectangle indicate the process. Process means then operations or the actions. And then if there are some alternative process, so we may represent those alternative process like using this kind of rectangle. Actually, this is not a rectangle, exact rectangle. This is a shape of rectangles which those corners are curved in shape, right? These corners are curved in shape, right? And then this is the decision symbol, right? Decision means a question or branch in the process, right? Sometimes we have to take the decision. So for example, in earlier case, right? So when you when you boil the kettle, right? So we have to when you are boiling the kettle, right? So let's take say after 2-3 minutes, we check it, right? So once if we boil up to the limit, right, then we can take it. Otherwise, we have to keep as it is, or we have to continue boiling, right? Have you got it? Likewise, we have to take the decision, right? Say so once you put the say 1 or 2 number of spoons of sugar, right? So once if you put say half of spoon, half say 1 spoon of sugar, then when you add what you call drinking that cup of tea, then we once if you feel that sugar amount of the sugar is not enough, then we have to put again, right? Likewise, we have to take the decision, right? So that's about the decision. And then next one is data input and output. So this is the symbol we represent the data input and output, right? And then so this is the symbol to indicate the start and the end of the algorithm, or we call start and terminator, right? And then this is the symbol we used for a connector, right? And then this arrow is used for flow lines, right? So, okay, let's take the examples, right? Then you will be realize how it is, those are used, right? And then computational algorithm means the computational algorithm can be used to develop solution for a particular task, right? So mainly there are two computational algorithms, pseudocode and flowchart, right? So the symbols that we have to use in flowcharts are explained. And then next one is flowchart. And then there are some guidelines for drawing flowchart. So first one is all necessary requirements should be listed out in logical order, right? So first of all, we have to consider that what are the requirements, right? So in the earlier case, our requirement is finding student ranking. So in addition to the finding ranking, the another requirement means finding the average, right? Likewise, there may be some requirements, right? Then it should be clear, neat, and easy to follow, right? That requirement should be clear. That's the first thing, right? So in our earlier case, the requirement is finding student ranking, right? So next one is only one flow line should come out from the process. That means once after the process, there should be a one flow line. That means if there is a process, there should be a one result. There should be a one output from the process, right? So we take one output from the process. And then only one flow line should enter a decision symbol, right? So when you are going to take a decision, we have to go with the one input, okay? But there can be two or more three flow lines, right? So one for each possible answer, right? Should leave the decision symbol, right? So next one is one flow line is used in conjunctions with start and stop, right? So you will realize these guidelines when you are drawing the flow chart, right? So I'll explain basic examples, right? The next one is the flow chart become, if the flow chart become complex, then it's better to use connector symbols to reduce number of flow lines, right? Okay, I'll take same example, right? How do you make this cup of tea, right? So this is the first one, right? So this is first answer. Now you can realize this, right? So the first one is, this is the first step, right? This is the starting step. That's why we use this symbol, right? So this one, right? So here, these are the symbols, right? So this is the start and end symbol. So this is process. So usually we use this process, start, end, and then this is input and output. This is a decision symbol, right? Decision symbol, right? Okay, then let's see this one, right? So right. Okay. So let's open this sharing. Okay, now can you see this? Can you see this presentation?
Yes, sir.
Okay. So this is the starting point, right? Take the kettle, and then we have to fill that kettle with water, right? So first of all, you have to check is the kettle is full water. So if it is yes, then we can boil the kettle. If it is no, we have to fill it. So these are process, right? So this is a decision symbol. We have to take the kettle, and then once we take the kettle, we have to check it whether that kettle is full with the water, right? So if it is yes, then we can boil. If it is no, we have to fill the kettle and then boil, right? So once we boil the kettle, then you can put tea in a cup and then pour boiling water into the cup, right? So here I don't mention that putting sugar and those things, right? So this is one method, right? So if you want, you can enhance this algorithm, right? Put tea in cup and then put sugar. Likewise, we can enhance this algorithm. We can add some additional process, right? So these are process, right? So these are process, right? This is a rectangle represent process. There are three process: fill the kettle, boil kettle, put tea in cup, right? Sometimes it may take these three process. Sometimes there may be two. So once kettle is filled, there are two process. So in here, this is decision symbol, right? So according to this decision, this path is changed, right? So this is the starting point, this is ending point, right? Start and terminate point. So right, in programming we call this termination, terminate, right? Okay, and then when you fill the kettle, right? So when you fill, so there are some alternate, there are some sub process. When you fill the kettle, how can you fill the kettle? Right, so we have to go to into the tab. Likewise, we can uh, uh, we can have some sub process. We call some sub algorithm. Right. So when you fill the kettle, right? So you have to place the kettle under the tap and then open the tap, and then you have to wait for filling. All right. So if kettle is full, then we have to close it. Right. So when you fill the water, we have to check it. Right. So if kettle is full, then if it is no, you have to wait. If it is no, we have to wait. Right. And same sub processing in boil the kettle. So when you boil the kettle, right? So in here, right? So these two main process, right, contain some, including some sub process. So when you are boiling the kettle, you have to check it, as I told earlier, right? So plug the kettle into the electrical shower, and then switch kettle on, right? Then we have to wait it. Then has the kettle boil, then we can, once it is boiled, if it is yes, then we can pour water into the cup. Otherwise, if it is no, we have to wait. We have to wait. Likewise, so inside the main process, there can be some sub process as well. Right? Now, do you understand it? You understand? Now, this is the
Yes, sir.
completing algorithm. Right? Take the kettle. If it is full, then we can, this kettle is full. If it is yes, then we can boil it. If it is no, we have to fill the kettle. Right? So inside the fill the kettle, there is a sub process. Inside the boil the kettle, again there is a sub process. Right? So once if we boil the kettle, then we can put tea in a cup and then pour boiling water into the cup. Right? So in this algorithm, there's no process called put sugar into the cup. Right? Right? So usually we don't use the sugar when we are uh, making tea. Right? Now, did you understand this? Next one is the, so when you when drawing the full algorithm, right? It should be started with the relevant symbol containing begin, and end up with the same symbol containing end, right? So as follows, right? So we have to mention begin and end point of the algorithm. Begin, and then there are some actions, and then end, right? So we have to mention beginning and termination, or we call end, right? So when drawing part of the algorithm, the oval symbol are replaced by the small circle called connectors, right? So if there is a part of particular algorithm, we can mention like this, right? So we can use this connectors, right? Connector symbols, all right? Then there is a one way to represent algorithm. The other way is using pseudocode, right? So pseudocode is an artificial and informal language, all right? So usually pseudocode is similar to day-to-day English, right? So, but this is not programming language, right? So that is pseudocode cannot be executed by the computer, right? So well-designed pseudocode can be easily converted into computer program in any programming language, all right? So algorithm can be represented using flowchart or pseudocode, and algorithm which is in pseudocode or flowchart can be converted into the any programming language, right? So usually in pseudocode, if when a full algorithm is designed using pseudocode, again we have to mention the beginning and end of the algorithm, right? So you use beginning, and then there may be some variable output message. Those are the actions, and there may be some calculations, and then output the result. Then at the end of the algorithm, we have to mention end, right? Okay, let's take example. How to put how to output message using computer program, right? We have to design the algorithm. Then we have to mention begin, and then output, say hello world. So this is the message that I want to output. Then output within bracket say hello world and end. So this is pseudocode. So this is flowchart. So begin and then output hello world, and then you need to terminate, right? So actually, this is not exact answer. So usually we use this not the this rectangle. If it's output, usually we use this what you call that some kind of a parallelogram, right? Parallelogram, right? So in programming paradigms, right? So there are fundamental style of computer programming. There are two main ways: the procedural programming and object-oriented programming, right? In procedural programming, in here, way of writing code as a list of instruction, right? And then telling the computer step by step what to do. And then programs are divided into sub programs, or we call sub procedures. In object-oriented programming, this is the way of programming organized around the objects rather than the actions, right? So in here we use procedural programming, right? So you will realize what is this procedural programming when you are doing the C programming, right? So you can't understand these two main programming concepts, right? So don't worry, right? So you will realize what is procedural programming when you are doing the C programming, right? I think up to this, right? Up to this, right? So we discuss algorithms using the flowcharts and pseudocodes, right? I think you got the things up to this, right? So no need to worry about this particular points, right? And then, so in procedural programming language, so we use basic C, Pascal, all those things. In object-oriented programming, we use Java, C++, Smalltalk, Python, and then all those are belong to object-oriented programming language, right? So in here we use a C programming language. So then we have to do the procedural programming, right? So we have to use the procedural programming, right? So again, don't worry about these codes, right? We discussed this codes in practical sessions, right? So this is the source code for the say printing hello world using C programming, right? So this is the source code in Java, right? So this is the source code in VB.NET, and then this is just for your reference, right? No need to worry about these codes, right? So this source code in C#, right? This is the source code in Java using the GUI, right? Okay, so in simple computational problem, right? So we have to develop an algorithm to get two numbers from the user and calculate the summation of those two numbers. Now we have to do this, right? And finally, you have to display answer to the user, right? So this is my question. You have to take two numbers from the user and calculate the summation of those two numbers and then output the answer. How can we do this? Right? You have to mention the algorithm, and then you can represent that algorithm using flowchart or pseudocode. Now, can you do this? Okay, then in here, so this is the starting of this algorithm. This is the starting, and then in here I prepare three spaces for two inputs, and then store the summation. So that is process. That is process, and then here I'll take the input for n1, so input for number one. So in here, input for number two. Here I do the calculation, that is summation n1 plus n2, and then here I output. Here I can say output summation is. I got it.
Yes, sir.
So that is output. Hello.
Hello.
Okay. So in here, right, to solve this problem, the procedure mentioned above has to be followed, right? So how can we do this? So these are the steps. So this is the abstraction of the problem, right? So here, what to do is consider rather than how to do. First of all, we have to consider what to do, right? What to do? Get two numbers from the user and compute the summation. And then third one is display answer, right? So these are the steps that we have to follow, or these are the things that we have to do, right? So here we call these are what to do, right? Then we have to consider how to do this, right? So developing an algorithm, right? So in here, how to do is considered, right? So the problem, first one is analyze the problem. In analyze the problem phase, we have to consider what to do, right? What to do in this problem. So what to do? Get two numbers from the user, compute the summation, and display the answer. Those are the things that we have to do. Then in step two, we have developing an algorithm, right? In here, we have to consider how to do this, right? So using pseudocode or flowchart, we can design the algorithm. If it is pseudocode, so earlier I mentioned the flowchart. So if it is pseudocode, it is starting from beginning, the word beginning. And then here we have to keep some space, right? Usually we keep tab space, right? So number one. So as I told you earlier, here we have to prepare three three spaces for storing inputs. Actually, two inputs and summation. Then number one. So initially I mentioned this is 0, right? And then number two, that is also integer, that is also 0 initially. And then summation. Summation is also 0 in initial, right? So at the beginning, number one is 0, number two is 0, summation is 0. We call these are initialization. Because initially we don't have value, right? So then next one is input. Input number one, input number two, and then we can do the process, right? Process is number one plus number two, and then assign the value to the summation, the variable called sum. Actually, these are called variables, as we will discuss these things in later. So for the time being, just say these are the spaces for, or these are the location for storing inputs. So this is the location for storing result, right? So sum is the result, and then we can output the sum. So these are two inputs. This is output, right? Then this is the end of this algorithm. Then I mentioned this is end, right? So in here we have to keep some space from the beginning point. This is the beginning. Actually, we keep some indent. So usually we use tab space in there, right? So this is pseudocode. This is pseudocode, and then next one is flowchart, right? So this is a starting point, right? So I have already explained. And then this is the process number one, number two. So it's better to mention these data types in here as well, right? So it's better to say number one is 0, right? So number two is 0, right? So because initially those are zeros, right? And then in addition to that, we can mention this type integer, right? So these are integers, right? And then next one is input number one, right? So after input the number one, then we can take the next input number two, and then do the process summation, and then we can output the summation, right? Of the summation or total. Then this is ending of the algorithm. Now, did you understand this? Right. So this is a pseudocode. This is flowchart. Right. Okay. And then program controls. Right. So controllers. Right. So statements in the program are executed one after another. One after other, in the order in which they have to do. Right. So usually program steps are one after another, and then they consider that the given order, right? So this is called sequential execution. Sequential execution means the statements are executed one after another in the order in which they have to do, right? So, however, the control structures allow the next statement to be executed other than the sequential order, right? So, if you want, there are some techniques we can change the sequential order, right? So, by using some conditions, right? So, let's consider how to change this, right? Then, what are the program controllers, right? So, the first one is the program can have three control structure. The first one is sequential structure. That means one after another. Sequential means one after another. Next one is selection structure. Selection structure. We can select a set of statements out. These statements should be executed first, then this stuff. Or depending on particular condition, if it is true, this statement should be executed. Otherwise, these statements should be executed likewise. Right? We'll discuss, right? And then repetition structures. Repetition means we have to do the same thing again and again. If you want to do same thing again and again, we can use a repetition structure. We call loops, right? So it is a sequence structure. So this is the normal execution of the instruction of a program, that is one after other, right? So one after other. So this is first action, second action, third action, likewise. So this is called sequence structure, right? And then selection structure, or we call conditional structures, right? Actually, conditional are where a section of code or a set of codes, or we call a collection of codes, right? Or usually we call section of code is only run, right? Is only executed if certain conditions are true, right? So we can mention some conditions. If those are true, then we can mention these statements should be executed. If those conditions are false, then we can say this statement should be executed, right? The most common conditional in any programming language is if statement, right? So let's see, right? There are three variants of if condition: if structure, if else structure, and nested if else, right? So let's see. Let's take the first one, if statement, right? It's a execute group of statements, executes group of statements only if certain condition is true. If certain condition is true, we can execute group of statements. Otherwise, these statements are skipped, right? Okay, let's take, right? So this is the flowchart, right? So we can consider condition. So if conditions is true, then we can perform the set of statements, right? Otherwise, if it is false, we can skip these actions. We can skip these actions, right? That means these actions are not executed, right? Okay, I'll take. So this is pseudocode. If within within two round bracket, we can mention the condition, right? If this condition is true, we can put into this block set of statements, right? So we can put the set of statements into this block, That means if this condition is true, these statements are executed. Otherwise, these statements are, that means if this condition is not true, or in other words, this condition is false, if this condition is false, these actions are not executed. Right? Okay, let's say take example. Right? So in here, it's a design algorithm to get GPA value from the user. Right? If GPA value is greater than 3.0, the research proposal is accepted. Right? Then what will happen if the GPA value is not greater than 3, or if it is less than 3, then research proposal is accepted or not?
Not.
Not accepted. So it's here, it's a if GPA value is greater than 3, research proposal is accepted. Otherwise, research proposal is not accepted. In here, they don't mention the otherwise statement. They mention only the if GPA value is greater than 3, then research proposal is accepted. Right? And simply we can say if your average, if your marks is greater than 50, you are pass. Likewise. Right? The condition is marks is greater than 50. In here, the condition is, so this is very familiar for you. So that's why I take this example. If GPA value is greater than 3.0, research proposal is accepted. Right? So then how can we design an algorithm? Right? First of all, what we have to do? How can you draw an algorithm for this? How can you do this? Right? So first one is start the algorithm. The next one is input the GPA. Then we have to take the decision. GPA greater than 3. If it is true, then we print the research proposal is accepted. Right? If it is false, then we come to here. That is, I skip this port. I skip this output. I skip. That means this. So what will happen if GPS is not greater than 3.0? This statement is not executed. This is not executed. So if it is greater than 3.0, then this is executed. If it is not greater than 3, that means if it is less than 3, this is not executed, then this statement is skipped. Right? You can see this part. This statement is skipped and then come here. There are two parts. Actually, this is branching. Right? This is branching point. Right? If it is greater than 3, then our program will come in this part. In this part. Right? So if it is not greater than 3, then what will happen? Then what will happen? Then it will come from this particular path. Right? It will come from this particular path. Right? I'll take a different color. Right? So in here. So if it is not greater than 3, it will come from this particular path. Right? So even this part or this part, right? So then this is continuing from here to there. That is it. Now, did you understand this? Did you understand?
Yes, sir.
Yes.
So, so this is a basic algorithm, right? But if you want, you can put some additional statement in here. Additional statement here. What is the additional statement in here? I can put some additional step in here. What is that step in here?
Process.
Sorry, process. What is that process?
Write down.
Sorry. No,
Note down.
no, we can say we can keep space for storing GPA. I can say GPA, that is initially that is 0, that is integer or floating point. Have you got it?
Yes, sir.
So no, that is not essential, but so this is the complete algorithm, right? So because I want to explain basics, so that's why I use this algorithm, right? Now, did you understand this one?
Yes, sir.
Okay. Then next one is if-else statement, right? So in here, execute group of statement only if certain condition is true. Otherwise, next statements are executed. Right? So in earlier, if GPA is less than 3.0, there is no statement. right? But in if else statement, right? So we can have a, if this is true, then we can have a set of actions. If this is false, right? If this is false, then we can have another set of actions, right? So even action one or action two, this is come to this particular connector, right? So this is pseudocode. If the condition is true, this set of statements are executed. Otherwise means if the condition is false, this set of statements are executed, right? So I'll take the same example, right? So design an algorithm which get GPA value from the user. If GPA value is greater than 3.0, this is the output. Your research proposal is accepted. Otherwise, it is not accepted, or it's a research proposal is not accepted. Now, can you draw the algorithm for this? Can you draw the flow chart for this particular problem? Can you draw it? Okay, so this is how we draw the algorithm, right? Start and input GPA, right? So before this, we can we can prepare a space for storing GPA, right? So input GPA, and if it is greater than 3, then we can have output say research proposal is accepted. So otherwise means if this is false, right? So if this is false, then we can say your research proposal is not accepted, right? Then we can come to the connector, right? And then end the program, end the algorithm, right? So that is the complete algorithm, right? So now you can see there are two paths, right? So among these two statements, right, depending on the conditions, depending on the this condition, right? So actually, depending on this output of this condition statement, this one or this one, or this statement or this statement will be executed, right? Not both, right? So one of them, right? So that means this algorithm or this flowing path is different, right? So it will be go into this direction, or it will be going or select this path, right? So the path will be green path or red path. So depending on this condition, right? Now have you got it? Did you understand?
Yes, sir.
Yes, sir.
Okay. So and then not only the if else, right, you can use the nested if else as well, right? So we'll discuss those things in next sessions, right? So if you want to grading, right? So if you want to grading marks, so for example, in your grading system, you have A grade, B grade, C grade, likewise, right? Depending on in earlier, we have only one condition, but if you do the grading, there are several conditions, right? So for example, if marks is greater than 75, you will get A. If it is greater than 65, you will get B. If it is greater than 55, you will get C. If it is greater than 40, you will get S. Otherwise, fail. Likewise, there are some several conditions. So if you have several conditions, we can have nested if else for algorithms, right? So and then I have another example, right? So say draw a flowchart and write pseudocode to find the average of two numbers, right? So if you want to find the average of two numbers, first of all, what we have to do, we have to take the inputs. We have to take two inputs and then do the calculation, take the summation and divide by 2 and then find the average like this, right? So I'm not going to explain deeply, right? Now you know input number 1, input number 2, and then take the average. The total and divide by 2, then we can output the average, right? So you can print or you can display, right? So both are correct. So this is flow chart. So this is pseudocode. Begin and input number 1, input number 2, and then calculate the average and output the average. And that is it, right? So actually in this point we can mention, if you want, you can mention. So we can prepare 3 spaces for store number one, number two, and average, right? So here also you can mention, right, if you want, right? That is the full algorithm, right? So this is the basic structure, basic of the algorithm, right? So this is flowchart, this is pseudocode, right? So it's a now you can do this part, right? Draw flowchart and write pseudocode to find average of two numbers and display pass if average is greater than 50. Otherwise, display fail. That is, if average is less than 50. That means the otherwise case in early. Now, what you have to do? Find the average of two numbers. That means you have to take two inputs. You have to take the two input and then find the average. So depending on the average, right? That means if it is greater than 50, you have to say pass. Otherwise, you have to say fail. Now, can you do this? Okay, I think some of you have done, right? So how can you do this, right? Start and then input number one, input number two, and then calculate the average, right? Taking summation of number one and number two, divide by two, and then what you have to do? You have to take the average and then you have to decide whether average is greater than 50, right? So if it is greater than 50, then that means if it is true, then we can say you are pass, display pass. Otherwise, right? So in here, if it is no, then we can say display fail, right? And then you can end to the algorithm, right? So it's better to put the connector in here and then draw a line like this, right? So it's better to draw like this, right? There's problem with this animation. So this is the pseudocode, right? Input number one, input number two, and then calculate the average. So this is the pseudocode for if else, right? So if average is greater than or equal 50, then the output is pass, right? So in here we have to keep some space, right? Keep tab space, right? So in here also we have to keep tab space, right? So if average is greater than 50, then output pass. Else we can output fail. And then here the if block is over. So this is the if block, right? So here we have to mention end if. End if means if block is end. And then here we can end the program, end the algorithm. Here we end the algorithm. In here end if means end the if condition. Here end means end the algorithm, right? Likewise, we can mention algorithm using pseudocode flowchart, right? So that's about the selection statement. And the next one is control structures, right? So actually, I'm not going to explain this one in deeply because in programming my practical sessions, I explain this loops, right? So for the time being, right? So we have discussed the simple sequence or the sequential order, and then we have discussed the selection statements. So depending on the condition, we can decide this path. And the next one is repetition structure or loops, right? So I'll take example, right? Now I want to print numbers from 1 to 10, right? I want to print numbers from 1 to 10. Okay, can you hear me? This, right? Now I want to print numbers from 1 to 10, right? So how can we draw algorithm, right? So please look at carefully, right? Start, and then I use there is so this is called variable, right? So x equals 0, right? Then I put x equals 0. Now the value of x is 1, right? And then value of x is 1. Then I put the condition. Now you know what is the condition, x less than 11. So now according to this value, this condition is true or false, whether this is true or false. Condition is x less than 11. The value of x is 1. Now tell me, This condition is true or false?
True, sir.
True, because x is 1, 1 is less than 11, right? Then come to here. So this is true. Oh, yes. Then I put display x. So then what will be the output? What will be the output? What will be the output in according to this statement? What will be the output? Display x. Now what is the value of x? What is the value of x?
1.
1. Then what will be the output?
100.
What will be the output? What will be the display? What will be the display value?
1.
1.
Number 1.
Yeah, number 1. That's correct. Very simple, right? Display x. That is output is 1. Right? Here the output is 1. Right? Is it okay?
Okay, sir.
Okay. Then what I am going to do, add 1 to x, or we call increment x by 1, right? Increment x by 1, or add 1 to x, right? So this is how we mention it, right? So actually, if it is this is not equal sign. This is in programming we call this is assignment symbol. Assignment symbol. Here 1 is assigned to x. 1, the value 1 assigned to x. In here, a 1 add to x. Now what is the current value of x? What is the current value of x?
1.
2.
No. Before this process, what is the current value? Before the process, in here, what is the current value of x?
1.
1.
1. Then here 1 add to x. That means here x is 1. Then I add another 1 to x. Then what is the value of x? Now
2.
what is the
2.
after this
2.
process? X will be 2. X will be 2. And then I return this process into here. Return this process into here. Now what is the current value of x is 2. 2. Current value of x is 2. Now what is the decision, or the what is the output? What is the decision of this condition? Whether
Yes.
true, whether true or false? True, or in other words, yes. Yes. If it is yes, what is the display value?
2.
2. Now output 2. Right? 2. Right? Likewise, here after 2, it will be added 1, another 1. Then what is the value of x? 3. 3 less than 11. Then output is 3. Then 3 add increment by 1. That is 4. Then 4 come to here. 4 less than 11. That is 2. Display 4. Then 5, 6, 7. Likewise, it will be go up to 10. Right? 10. Then once if you do it 10, 10 increment by 1, or 1 is added to 10. Then what is the value of x? 11. X will become 11. Then once x will become 11, then what will be the result of this decision? Whether yes or no?
No.
No.
Oh,
Then it is no, then it's come to out from this decision, then end the program. Now, did you understand this?
Yes, sir.
This is called repetition structure, or this is some kind of loops, right? So depending on this condition, that's the output of this condition, this a number of repetitions are decided. Number of repetitions. In here, 10 number of repetitions. Have you got it? 10 number of repetitions, 10 number of loops, or we call, actually in programming, we call those are iterations. Iterations, or iterations. Here 10 iterations are executed. After 10 iterations, once this condition is false, then exit from this loop into the from the program. Exit from the loops. Exit from the loops. Have you got it? Have you got it?
Yes, sir.
This is called while loop. This is called while loop. This is how we mention in pseudocode, right? Begin, and then x is 1, and then this is the loop. while x is less than 11. While x is less than 11 means since this condition is true, this block will be executed. This block, right? So this is the block, right? So this block is indicated by tab space, right? So while, and then this set of, so since this is correct, so since this is true, these statements are executed. While x less than 11, so first of all, what x is 1 less than 11, that is true, then output 1, then 1 is added to 1, 2, then it will go to here, 2 less than 11, that is true, therefore output 2, then increment by 1, then x become 3, 3 less than 11, then output 3, 3 plus 1, that is 4, 4 less than 11, that is true, come here, then 4 increment by 1, that is 6, sorry, 5, 5 less than 11, that is true, output 5, then 5 add 1, 6, goes to here, 6 less than 11, that is 2, output 6, 6 plus 1, 7, then goes to here, 7, 7 less than 11, right? That is 2, output 7, 7 plus 1, 8, then 8 less than 11, that is 2, output 8, 8 plus 1, that is 9, then goes to here, 9 less than 11, that is true, output 9, 9 plus 1, 10, then goes to here, 10 less than 11, whether it's true or false,
False.
10 less than 11, 10 less than 11,
True.
True.
true, then
True.
output 10, 10, 10 plus 1, 11, then goes to here, 11 less than 11, now
False.
it's
False.
false. Then once if it is false, then out from the loop,
End.
then come to here. If there are some statement in here, those are executed, right? But in here there is no statement, therefore go to it. Now did you understand this?
Yes, sir. Yes, sir.
Okay. So
Yes, sir.
that is the loop, right? While loop, right? So we can do those things in programming practicals, right? So this is one loop. There are some other loops as well, for loop and do while loop, right? So we can discuss those things in programming practicals, right? By the way, did you understand up to here?
Yes, sir.
Okay. So once if you understand this, then try to do this, right? Draw flow chart to find largest number among three numbers. Among three numbers. That means you have to take three inputs. Have you got it? You have to take three input from the user and find the largest number among the three inputs. Did you understand the question? Did you understand the question? You have to take, not now, right? So when you come to the next class, try to do this, right? You have to take three inputs from the user and find the largest number among the three inputs. Did you understand? Did you understand the question? Okay, then I'll stop in here. Please send your registration number and name, right? Okay.